All right, on number 28 it says, does the graph above represent the graph of a function? Well, it certainly passes the vertical line test, so that would be a yes. Again, you can just draw vertical lines going this way, and if you can, as long as you can't go through more than one point, the answer is yes, it is a function. All right, on number 29 it says, over what intervals is it increasing? So we got increasing, decreasing, and constant. I want to remind you of a couple of things here. First of all, these are x intervals, and in fact, in each case they're open intervals, so we're going to be using parentheses. So we're going to start going from left to right. So notice this function's coming from negative infinity, or it goes out to negative infinity. So from left to right, it's negative infinity until x gets to negative 2. And so over that interval from negative infinity to negative 2, this function is decreasing. So negative infinity to negative 2. So again, we're reading along the x values and we're going from left to right. So now we're at negative 2, and now what's happening? Notice we're constant. So from negative 2 until we get to 0, we're constant. So that's on the interval from negative 2 to 0. So now you can see we're going up, rising or increasing, and that occurs from 0 to 1. And finally, from here to here, so from 1 to 3, we're decreasing again. So we use the union symbol, or sometimes people put a comma in between, but that's how we would represent the two different intervals where it's decreasing on this graph. It says, what's the domain of the graph in interval notation? So for the domain, we're going to be looking at the x values. We're going to go from the leftmost point to the rightmost point. Well, there is no leftmost point. This graph goes forever left. So we start out in negative infinity land, and we keep going to the right and to the right, and eventually we end up at that point right there. That's our rightmost point. And the x value, because again we're working along the x-axis here, left to right, is x value is 3 there. And notice that point is on the graph, and so we do use a bracket here. So when we determine the range, now we're going to go along the y-axis from the lowest values to the highest. And so our lowest point is that point there. And the y value there is negative 1. So we're going to start at negative 1. Oh, and I made a mistake there. Let me fix that. So that should be a bracket. Let me fix that. Should look like that. And then our highest point, notice right there, we're going to go left, but we're also rising, and it'll rise forever. We assume that it keeps going in that direction the way that it's drawn, and so there is no highest point, so we say negative 1 to infinity. There is no highest y value on this graph. All right, let's move on to 34. What is the value of f of negative 2, assuming we call this function f? Well, here's where x is negative 2, and if you look above, you can see the point on the graph that has an x value of negative 2. The corresponding y value is positive 2, and so f of negative 2 is 2. You might even say, normally we say equals 2. F of 1. So in both of these cases, what we're given is an input value or an x value. So x is 1 here. So we go to where x is 1. And notice up above, that's where the graph has a point on it that has an x value of 1. That's the point 1 comma, well that would be 1 comma 3. So f of 1 is equal to 3. Now there's another way to look at this. Notice that when x is negative 2, so for number 34 we're finding f of negative 2, when x is negative 2 the height of the graph is 2. It's up 2. So f of negative 2 is 2. When x is 1, the height of the graph is 3. So f of 1 is 3. So let's do the same thing for f of 0. When x is 0, the height of the graph is 2. And so f of 0 is 2. So in each of these 3 problems, we were given an input, and we gave the output. And again, these outputs, or y values, can be thought of in terms of the height of the graph. So for number 37, notice now we're given the output, or the height of the graph. So what I want to do is look on this graph and see if I can find a point that's down 1. So I've drawn a line where y is equal to negative 1. So all of those points are down 1, and so this is the point on the graph that's down 1. And so that happens when x is 3. So again, we're going backwards from what we were given before. We're basically given a y value or an output, and we have to find the x value or the input. So in number 38, f of x equals 3. Our output is 3. Our height of the graph is 3. Well, that happens right there. Well, notice there's 2 points that have a height of 3. That one there and that one there. So when x is negative 3 and when x is 1. There's 2 points where the height of the graph is 3. When x is negative 3 and 1. In fact, f of negative 3 is 3 and f of 1 is 3. There's 2 values we could plug in and we get an output of 3. Alright, last one on this page. It says if the graph above is a picture of f of x, then where would the original point 1, 3 move if instead we graphed y equals f of x plus 2 minus 3? And then we're supposed to give the points new coordinates. So we've got the point 1, 3 right there. Now look at the function here. F of x plus 2, that plus 2 is inside with the x. It's going to cause a horizontal shift, and that would be left 2. Remember, horizontal shifts work backwards. I would have thought you go right 2, but you actually go left. And that minus 3 is going to cause a vertical shift down 3. And so what's going to be our new coordinates? We're going to move the point 1, 3, left 2, and down 3. And you end up at that point negative 1, 0. So that's the coordinates of the new point. So we could move the whole graph like that, but we're just moving that point. Let's move on to 40. It says below is the graph of a function f of x. On the same coordinate plane, graph the function y equals f of minus x. Well, let's see. F of minus x is going to be a reflection. Now, if the minus was out in front of the function, we would be going through the x-axis, which is the most common case. But in fact, here, we're going to go through the y-axis. So we're going to go that direction. So this is we're going to reflect through the y-axis, which is right there. So we want to remember we're reflecting through that axis. So for this point here, we're 1 over to the right of the y-axis. That means we have a point on the other side, 1 left of the y-axis. So for, let's see, I think we did, yeah, that point there next is on the y-axis, so it won't move. Now this point here is 2 to the right of the y-axis, so there should be a point 2 to the left of the y-axis. And let's look at that point right. Well, actually, let me back up a sec. Whoops. I need to go to the next page here. Sorry about that. I got a little bit carried away. Hold on a second. So here's where we were. So So next we're going to deal with this point here, and it's 1 to the left of the axis, the y-axis, so we need to go 1 to the right on the opposite side. So again, we're reflecting through the y-axis. We're 1 to the left, we're going to have a point 1 to the right. And then finally we have this point here that we need to reflect. Notice it's 3 to the right of the y-axis, so there should be a point on the other side 3 to the left. So when you're done, you should get a graph that has the same shape. It's just everything's been moved, or it's been reflected. Each point has been reflected through the y-axis. All right, on number 41 it says we've got this graph, and we're supposed to adjust it, let's see, according to the shifts here. It says y equals g of x minus 8 minus 1. We know that minus 8 is inside with the x, so that's going to cause a horizontal shift. That'll be right 8. And the minus 1 is going to cause a vertical shift. It'll be down 1. So we're going to move each point left 8 and down 1. I'll start with this point right here. So when you move it down 1 and right 8, you end up right there. And so I'll do the same thing with the other 3 points. And you end up with those 3 points there. And let's go ahead and draw the graph. And so that is our graph. Let's move on to 42. So these 3 problems at the top here, we're just doing the AC method. So I'm going to go through these pretty quickly. This is all review. So we need 2 numbers that multiply to AC. That would be 3 times negative 8, negative 24, and add to negative 2. That's our B term, the number in front of x. And so the numbers are going to be 6 and 4, and the 6 should be negative. So notice when you add negative 6 and 4, you do get negative 2, and we multiply, we do get negative 24. So because that's a 3x squared, we're going to have to go the long road here and split our b term. So we drop the 3x squared, and using the numbers we just found, we're going to split our b term into these 2 x terms. And don't forget to bring down the 8, and then we factor by grouping. So here we can factor out a 3x times x minus 2. And when you factor out a 4 in the next 2 terms, you get 4 times x minus 2. We know that we should always get the same thing inside the parentheses there, and that's what happened there. So we get x minus 2, our common factor, times the leftover factors, or the leftover part there, which is 3x plus 4. And if you ever needed to check it, you could always FOIL this, and you should get what you started with. On number 43, we need 2 numbers that multiply to 24 and add to negative 11. So again, I'm going to split my b term. The numbers that work are negative 3 and negative 8. So let's split our b term, and we get 6x squared minus 3x minus 8x plus 4. So the first 2 terms we can factor out a 3x, the GCF of 3x, times 2x minus 1. So when we factor these 2 terms, we're expecting to get a 2x minus 1. So to get the negative 8x there, we need to multiply by negative 4. And notice negative 4 times negative 1 does give you 4, and so we're good. So we're going to get 2x minus 1 times 3x minus 4. All right, last one of these. Let's see, we've got 7 times 10, which is 70. Adding up to 37, well, that's interesting. So in a case like this where the numbers add up to a pretty big number, it's probably one of our extremes. 1 times 70, that's not going to add up to 37. But what about 2 times 35? So those are the numbers that are going to work. So again, let's go ahead and split our b term and factor by grouping. Notice x is the only common factor there, times 7x plus 2. And we're expecting when we factor this part, we'll get a 7x plus 2. So to get that 35x, I need to multiply 7x by 5. And notice 5 times 2 does give you the 10. And so we're going to end up with 7x plus 2 times x plus 5. All right, let's look at number 45. They're asking us to use the quadratic formula. So first of all, do you remember it? Well, let me go ahead and write down my numbers here. That's what I had set out to do first. So a is 1, b is 8, and c is 12. Quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. And so let's plug in our numbers. So minus b, which is going to be negative 8, plus or minus 8 squared minus 4 times 1 times 12, and over 2 times 1. So we have negative 8 plus or minus. Now inside here we're going to get 64 minus 48. 4 times 1 times 12 is 48, which is 16. Now keep in mind, it's the square root of this, square root of 16, over 2, 2 times 1. But we know the square root of 16 is 4. And in fact, we got two answers here, negative 8. Oh, I forgot my plus or minus in that. Let me put that right there. Whoops. That's a plus or minus. That wasn't a very good minus. Let me try one more time here. Okay, so still not very good, but hold on a second. I'll fix this problem. That's going to have to be good enough. So negative 8 plus 4 over 2 is one of my answers. That's negative 4 over 2, which would be negative 2. And the other answer would be negative 8 minus 4 over 2. Negative 8 minus 4 is negative 12. So we're going to end up with negative 6 there. All right, we got two more problems to go. We're going a little bit long, but we're going to go ahead and finish here. So we got some rational expressions to add together. So notice on that first problem we can factor out an x, a GCF of x. So we have x times x minus 2. So if you look at all our denominators, there's really only two factors, x and x minus 2. So I'm going to cross that out and replace it with x times x minus 2. And that's our LCD. I'm getting tired here. So we need to rewrite the fractions so that they have that LCD. So notice the first fraction has an x minus 2 factor, but it needs the x factor, doesn't have that. So we're going to multiply the denominator by x. In order to keep it legal, we have to multiply the numerator times x. So what we're really doing is multiplying by 1 and rewriting the fraction. Notice if I crossed out my x's, I'd be back to where I started. So by multiplying by x, we're able to get the denominator we need. Now, for the middle term, we have an x in the denominator. We need the x minus 2. So we'll have to multiply the numerator by x minus 2. And 1 times x minus 2 is x minus 2. And then it's minus negative 2. So we're going to add our numerators now that we have a common denominator. So we got x times 3x, that's 3x squared, plus the 2 times x is 2x. And then we're going to add x minus 2 there. And then minus negative 2, that's going to be plus 2. And that's our numerator, and then our denominator is x times x minus 2. I'm just going to put LCD here to save a little time. And we have some like terms we can combine together. We end up with 3x squared plus 3x. Notice a minus 2 and a plus 2 add up to 0. And of course 2x plus 1x give you the 3x. So it's 3x squared plus 3x over x times x minus 2. Notice I've kept the denominator in factored form. We want to keep it that way because at the end we always got to make sure our answer is simplified. So here we can factor out a 3x. It'll be 3x times x plus 1. In the denominator we have x times x minus 2. So you can see our x's cancel and we're left with 3 times x plus 1, the quantity x plus 1, all over x minus 2. So 47 is very similar, in fact. Look at the right fraction there. It looks like that's factorable. And sure enough, we're going to get the two factors that are in the other two fractions. Two numbers that multiply to 30 and add to negative 11. That's going to be negative 5 and negative 6. When we multiply, we do get 30, and when we add, we do get negative 11. So let's go ahead. We can take the shortcut here. It'll be x minus 6 times x minus 5, which are the other two factors. So again, LCD is just those two factors. That's the only two factors we have. And we're going to rewrite so that all of our denominators have that denominator. And I made a mess of things there with my little marks. So for 5 over x minus 6, I'm missing the x minus 5 factor. So I got to multiply by x minus 5 over x minus 5. And so 5 times x minus 5 becomes my new numerator. And then on the next fraction, I need to multiply by x minus 6 to get my LCD. Okay, so I have to multiply the numerator by that. So it'll be minus 7 times x minus 6. So we will have to be careful there. We're going to be distributing a negative 7. And then finally, notice we don't have to change anything on the last fraction. That's just 7 over x minus 5 times x minus 6. So now we're ready to add and subtract our numerators. And we got 5 times x minus 5 minus 7 times x minus 6 plus 7 all over our LCD, x minus 5 times x minus 6. So I need to clean things up in the numerator. Let's distribute. We get 5x minus 25 there. Negative 7 times x is negative 7x, and negative 7 times negative 6 is 42. And then bring down that plus 7. And let's see, we have some like terms we need to combine together. 5x and a negative 7x is negative 2x. And if you add negative 25, 42, and 7, you get 24. So our denominator, we shouldn't write LCD. Let's write it out now. X minus 5 times x minus 6. Now you could factor out a 2 in the numerator, but that's not going to help you to do any canceling. So I'm just going to go ahead and leave it like it is, but you could have done that, and that's no big deal. And we're done. That's the end of the video for this review.